Fifth graders, today is Thursday, December 12th, and today we're doing lesson 3.4, module 3, lesson 4. And today what we're going to do is we're going to add fractions, and we know that the sum, which is the answer of the addition problem, is going to be between 1 and 2. Okay. We've learned so far to add fractions that have like denominators. We've also learned how to add fractions that have unlike denominators. So today we're going to look at to see what happens when the answer is somewhere in between 1 and 2. Before we do any mathematic calculations, I just want you to think about what you know about fractions, okay? And I want you to think if the answer is going to be more than 1 or less than 1 and why. So for our first problem, it's 1/3 plus 1/4. Do we think the answer is going to be more than 1 or less than 1 and why? Let's think about it. What is exactly half of 1? 1/2, right? So if I had 1/2 plus 1/2, that would be exactly 1. Is 1/3 more or less than 1/2? Less. Okay, so this is less than 1/2. Is 1/4 more or less than 1/2? Less. So if I take something less than 1/2 and I add something less than 1/2, is the answer going to be more or less than 1? Less. Okay, so we think that this one will be less than 1. Okay. What about this one? Let's try this one. 1/2 plus 3/4. Do we think that will be more or less than 1? And how do you know? Write the problem down in your notebook and then justify it. I think 1/2 plus 3/4 will be more or less than 1 because, again, I want you to think about the size of fractions because it can help you make sure your answer is reasonable. If we solve the first problem, 1/3 plus 1/4, and we end up with something more than 1, right away you should have an alarm going off in your head saying, wait, that's not reasonable, right? Or if we solve 1/2 plus 3/4 and we end up with something less than 1, again, that alarm should go off and say, hold on, something smells fishy here. It's not quite right. Okay. Now that we've made our predictions, let's use a rectangular fraction model to solve. We know that 1/3 plus 1/4 have different denominators, so we have to come up with a different version of the problem that has like denominators. So when I overlap my rectangular fraction models, I can see that 1/3 is equal to, how many parts are now shaded in? 4, out of a total of how many parts?
12.
So 1/3 is the same as 4/12. And 1/4 is the same as, I can see that there are 3 parts shaded in, and there are 3 parts shaded in, and there are 12 altogether. So 1/4 is the same as 3/12. So I could rewrite this problem as 4/12 plus 3/12, which is 7/12. Is 7/12 less than 1? So does our spidey sense feel okay? It feels okay so far? We feel like we probably are right? It's reasonable? Good. Let's try the next problem, 1/2 plus 3/4. Do we have like denominators? No, so let's make them like. We can show that this is 1 and this is 1/2. Right? And then we can show that we're adding it to another rectangle that's worth 1, but this time we have 3/4. Shade in 3/4. And of course I have to label that it's 3/4 in order for it to be accurate. Okay, if I overlap them, I find out that 1/2 is the same as 4/8, and 3/4 is the same as, how many eighths? 6/8. Good. So now I have to do 4/8 plus 6/8, which is how many eighths? 10/8. Good. Now how many eighths does it take to make one whole?
8.
Are there 8 eighths and 10 eighths? Yeah, I basically can think of 10 eighths if I have a number bond. I can think of 10 eighths as 8 eighths plus another how many eighths? 2 eighths. So if I separate out the whole number, how many wholes do I have? 1. And then what's the fraction part?
2.
Good. And this is called a mixed number, where we write a fraction right next to a whole number. It's the same as saying 1 plus 2/8, but we don't actually need the plus sign. We could just write it as 1 and 2/8. When we have a mixed number like this, the word form to say it is 1 and 2/8. Does that make sense? Not 1 2/8. It's 1 and 2/8. Does this fit with what we expected, that the answer should be more than 1?
Yeah.
Very good. When we have more than 1 as a fraction, look at this, 13/10. You can notice that it's more than 1 because the numerator, 13, is larger than the denominator of 10, right? That means that we have at least 1. What we call it an improper fraction. Improper fraction. When the numerator is larger than the denominator. Because it means that it can be simplified to a mixed number. We have to take out the whole to simplify it. Does that make sense? It's improper if the top part is bigger than the bottom part. Make sense?